All right, so let's discover Earth. Now, this here is something super familiar, right? I mean, I even just kind of gave you the answer. It's Earth. So we have this cool image of Earth. Now, it's not just a static image. It's not just a picture. This is actually something that I can control. Did you know I can control Earth? I can on an app. Now, this is actually an app that you can download if it's something that you would like to explore too. So it's right down here. That's the name of it. It's called NOAA's SOS Explorer. Now, NOAA is the National Oceanic and Atmospheric Administration. Basically, a lot of us know about NASA, right? NASA is the government agency that belongs to the United States that explores space and takes a look at space and helps us know about it. But Earth is important too. And that's what NOAA does. So NOAA really does a lot of things for the Earth. Now, the Earth is comprised of lots of things, right? There is the ocean, and NOAA takes a look at the ocean. And there's also the sky, so the air, the atmosphere. And that's something that NOAA is looking at as well. So all of the data, all of the images and information that we're seeing here is really courtesy of NOAA. And we're really, really lucky that we have them. And then, okay, SOS Explorer is the name of the app. So you can actually go to whatever app store you have and look up SOS Explorer and download this on your own. And then you too can control the Earth. So I keep saying I can control the Earth, but you don't see that happening, right? Well, that's because I need my device here. So I have a tablet, and this tablet here will allow me to control the Earth. So if you wanted to see the other side of the Earth, I could actually spin it. You want to see the bottom of the Earth? We can do that too. So it's actually a pretty neat app for us to be able to really take a look at Earth in a whole new way. It's like having, in a way, a digital globe, okay? So this digital globe shows us Earth, but we know it. We're like, okay, yeah, okay, it's Earth, whatever. But how did you even know it was Earth? What are the things that you saw that reminded you that this is our planet? It's not Mars, it's not Venus. What are the things that you noticed here that told you what you were looking at? Now, when you are exploring, that's one of the things that you really want to do. You want to look very carefully, and you want to make a note in your head, or even if you wanted to draw or write things down, make note of the things that you observe, even if they seem really obvious. Like for us, this is obviously Earth. We've seen pictures all over the place. But what is it that tells you that it is Earth? Now, a lot of people say, well, like the continents, right? Because like for us, this continent right here is pretty familiar in the United States because it's where the United States is located, right? So that's North America. But it's not just it's not just this continent here. It's that there's other continents that help us know that this is Earth, like South America. And if we even spin this around, you can see other parts of our planet as well. And now I'm going to change things up a little bit. So as you can see here, we have nighttime on this side here, and we have daytime on this side here. So I'm going to change this up so we can get rid of nighttime and we can see the whole planet. And if you wanted to do this and you're like, how did you do that? And you downloaded the app, or you're going to do it in the future, you go to the tools, and that's right there. Right there. And then when you open up tools, this little window pops up. Go to settings, and then you have the settings. This one here in the center, it's that's the split. So if we hit it again, the nighttime comes back, or we can make it daytime. Cool. And then if you didn't want to look at the clouds, you can even turn off the clouds. So we've got a lot of power here, right? Okay, let's put some clouds back. They're kind of pretty. So let's look at the rest of the Earth, right? So here's Asia, down there's Australia, there's Africa, Europe. So the orientation of all these land masses tells us that this is our planet. This is recognizable. And we know that these are land masses because of the colors that we see. So on our planet, our land masses tend to be green, tan, even kind of like a reddish color. I just love that color. And browns. And so those tell us that these are the land masses. It even tells us a little bit about what you would find in that area, right? Because those different colors are made by different things. The green is plants, and this kind of lighter tan is probably more like sand. So we know a lot about the land masses, but wait a minute. If you really look at Earth, there sure is a lot of blue. In some ways, I almost think of this as being planet ocean, because there is so much blue, and the blue, of course, is the ocean, right? Or water. We're used to seeing it that way. And this is the Pacific Ocean. Now, wait a minute. If we look here, the Pacific Ocean is enormous. And that's very true. The Pacific Ocean is quite enormous. And that's one of the reasons why it takes up basically the whole planet when we're looking at it in this view. Okay, so we know that this is Earth. We've looked at land masses. We've looked at the ocean. There's also all the white stuff that's kind of around here. I already kind of mentioned it. Those are the clouds. And then, of course, if you look toward the top of our planet, so this is the northern hemisphere, we have the Arctic. And that's white as well. And that's all of the snow and ice that's floating on top of the water in the Arctic. And then if we go to the bottom hemisphere, the southern hemisphere, there's also some white down there. And this is actually snow and ice that's on top of a landmass. This is Antarctica. So we're kind of oriented now on our planet here. But how did we even get this? Where did this image come from? Just take a moment. How would you have gotten this picture? Is there an astronaut floating in space in a spacesuit taking pictures around the entire planet? Probably not that exactly, right? In fact, it is much easier to get these images from a satellite. So a satellite is basically a robot that can be sent up into space, and it can orbit our planet, or it can even stay kind of in one spot, like say even over Long Beach. And then as the Earth rotates, as we do, it rotates with us, so it always stays over Long Beach. So that's another thing that a satellite can do. Some satellites go around and around and around, and some just kind of hover over one spot and follow the rotation of our planet. So those satellites out there are looking at all kinds of different things. For this image here, it was really just looking at what the Earth looks like. It's almost like it was taking pictures. And those pictures were woven together into a sphere form, so into this nice ball form. And that's how we got this image here. So at any one given time, the Earth probably doesn't look exactly like this, but that's okay. It's still Earth. It's still pretty cool. It's a great place, right? All right. Now, what else can satellites look at? Well, it can look at all kinds of different things. Satellites help us with weather. Now, I had mentioned earlier NOAA, the National Oceanic and Atmospheric Administration. They are actually one of the main folks out there that is using these satellites to take a look at our weather. So if you've ever looked at a weather forecast before, a lot of times that information is actually coming from satellites. And a lot of them are coming from NOAA's satellites. So that's pretty amazing. So thanks, NOAA, for that, for that information, right? Because it's nice to know when it's going to be hot outside and you want to dress in clothing that helps you with that, or when it's going to be cold outside and you need to bundle up. So NOAA is really, really great for that kind of information. Now, it's not just images like this that we're going to get. We can actually look at other kinds of data too. Now, I'm going to load a data set. Basically, a data set is a whole bunch of information that is gathered together. And NOAA actually took that information and then translated it into a picture. So I'm going to pull this up, and I want you to look at it and try to figure out what's going on. Now, earlier we looked at shapes, we looked at colors of our planet here, and that's how we knew that this was our planet. Now let's take a look at this. It does take a moment to load, and once it's loaded, it does take a moment to render, so to get kind of clear. But now we have this whole other image. Does it still look like Earth? How did you know? So yes, it does, right? It is still Earth. And we know that because if you look at the gray masses here, those are the land masses. So the colors have changed. The ocean is no longer just blue. The land masses are no longer green, tan, brown, red. They're gray, right? So, okay, our oceans have really changed color. Now, do you think this is what they actually look like? Yeah, no, not so much. This is a picture representation of what the ocean might look like. But what are we looking at? Now, one of the best things to do when you're trying to figure out what you're looking at is to look for titles, look for keys, right? Something that's going to give you a little bit of information about it. Right down here, you'll see the title of this data set. It's Sea Surface Currents and Temperature, Vegetations on Land. Okay, so we're looking at sea surface currents. And the whole reason why it's specifically sea surface and not just ocean currents is because there are currents that are kind of towards the top or surface of the ocean. And then there's currents that are deeper into the water of the ocean. And the temperature is also different when you go deeper into the ocean. So we're very specifically looking at the surface. Okay, and we are looking at temperature. So how do you know what degrees the temperature is being represented here? Well, this is the key here. This is the sea surface temperature. Now it is in Celsius, and so so that's something to kind of note. But you'll notice here 0 is blue, and 32, which is warm, is red. So this color bar here, or kind of this rainbow color bar here, tells us what the temperature of the water is at the surface. So let's take a quick look here. Now, I am in Long Beach, California. That's basically about right here. Okay, so what is the water like here? Is it warm? Is it cold? Is it somewhere in between? Well, if we take a look down here, it's kind of like a greenish blue color. So it's about like right maybe there. That's on the cooler side. And I can confirm that. If I haven't been to the ocean recently, but if you were to go down to the beach and you were to stick a toe in the water is actually pretty cool. And on a hot day like today, it's pretty refreshing. Okay, so we know that right here is pretty cool. But if you were to go, say, maybe to Alaska and dip your toe in Alaska, take a look at the color difference. The color difference tells us that the temperature difference is pretty dramatic. So down here, Alaska is a much, much colder place. And if you were to even look a little further up, really in the Arctic, look at how deep that blue color is. And that tells you that it's very, very cold. All right. So we have seen cold. We've looked at cool. What about warm? Well, let's take a look on the other side of the United States. What about Florida? Wow, that's very different than California. What's so interesting is if you really just draw a line across, it's kind of on the same same plane, right? But because the ocean moves differently in the Pacific here, versus the Atlantic over here, we're actually getting a different temperature. Okay, so over here you're seeing more yellows, more oranges. And another thing too is if you actually look up high right here, this tells you what date it's looking at. So right now it is June of 2007, so a little bit ago. But it's still very, very similar. A lot of the movement is the same. A lot of general temperatures is the same now as it was in 2007. It's been warming some, but you get a good general idea. So let's take a look here at the Atlantic Ocean. Why is it that the ocean is so orange here? Why is it that it's so warm here versus so much colder up in the North Pole? Now we know here in the Arctic that there's a lot of snow and ice, and so maybe that could cool water down, right? Yeah, that's possible for sure. But did you know that it's because the sun actually hits our planet differently near the equator or the center here versus the top of the northern hemisphere? So our planet isn't just like straight up and down, and north is right here and south is all the way down like where my toes would be. It's actually a little tilty. And the tilty thing is a good thing. That's what gives us our seasons. That's how come we have spring and fall and it's not just the same temperature all the time. So we want that because this is kind of what we're used to. This is how we've adapted, right? And so the equator area of our planet gets more sunlight, more direct sunlight, and more of that direct sun heat throughout the year because it's actually just a touch closer. All right. Whereas the very north and the very south of our planet, it doesn't get quite the direct sunlight the same way. And so that's why it's a lot cooler here. But then if you take a look in between the north and the equator, what's going on there? You may notice a whole lot of swirls, and that's right. There's a whole lot of swirly going on, and that's because the ocean is always moving. So, so we're looking at a lot of small swirls, but at the same time, there's this big ocean current that's basically going this way in the north. Okay, and that's one of the reasons why along the east coast over here, the water is actually quite warm. And I was really surprised. I lived in Washington, D.C. for a little while. We went to Virginia, went to the beach, and I was like, oh my gosh, it's such a hot day. I can't wait to get in the water. It was the summertime because, you know, what I'm used to over here in Southern California was that the water was going to be refreshing and cool. And I touched the water, and it was very warm. It was like bath water. And that kind of tells you here, this shows you here, why? Because this warm water from the equator is actually moving up and along the east coast of the United States. And so this water is quite warm. And then as it moves up, it gets cooler and cooler and cooler. It gets much cooler here. As it moves down, it starts to get a tiny bit warmer. And then as it hits the equator, it's really warming up. And then that cycle happens all over again, right? Okay, so that's what the Atlantic looks like. What about the Pacific? Why is it that in Southern California it's cool? Well, it actually moves the same way, right? So we're down here. The water is moving this way towards Australia, and it's quite warm. And as it moves up here, it's still quite warm, just like going up the coast of the eastern United States. Then as it hits Japan, it's getting a little cooler. Gets cooler up here, and then as it comes down the North American coast here, all right, so as it comes down here, all that cool water is warming up a tiny bit. And that's actually why we get cool water, because our water is being cooled up in the north, and then it comes down towards us. So it really is like this giant kind of circle that is moving the water around on our planet. Why do we care? What does this matter? Well, it matters a lot because it changes our climate. It changes the temperature and the humidity and the storms on land. This is actually one of the reasons why hurricanes that actually are generated in warm water and are fueled by warm water, it's why Southern California doesn't really get hurricanes. The water here off our coast, the ocean, is cool. And so those types of storms don't have fuel to keep going. Whereas on the East Coast with that warm tropical water, it fuels those hurricanes. And that's why the eastern coast of the United States tends to get hurricanes. So we know that the ocean actually has a huge influence on the temperature and the climate that we have on our planet, on land. But what about all those animals out there? Now, we can actually use information like this to take a look at maybe animal migration. Why do animals live in a certain area? Now, I really want to focus on penguins today because penguins are pretty awesome animals. Now, what do you know about penguins? Where do they live? Okay, do they live up here? Polar bears live up here. Polar bears are one of my favorite animals. And polar bears live up here. And we do see a lot of pictures like cartoons and stuff of penguins and polar bears hanging out. But penguins actually don't live in the northern hemisphere. Penguins are found in the southern hemisphere. Now this map here shows us where penguins are located. All of the blue that you see are penguin lives, penguin habitat. And this right here is kind of stretched out a little funny because the map is now flat. But this is Antarctica. Okay, so that's the southern part of our planet here. As you can see, North America, South America. So we actually do have penguins that go pretty far up. The equator is basically like right here, right? So there are some penguins that live pretty close to the equator, but none up here. All the penguins are down here. why is it that penguins don't live up there? Why don't some of them say, hey, I want to expand and I want to go visit another place? You know, this is actually a question that I've been asked by a few people. Well, let's go back to the data. Let's go back to our Science on a Sphere, our SOS Explorer. Okay, so we know that penguins are found down here. Take a look around Antarctica. What do you notice around this continent? What do you see? A lot of squiggly lines, for sure. But do you notice that it's very blue? It's very cool. Now, a lot of us also think that penguins really do live where there's always going to be ice and snow. But that's actually not totally true either. There's a handful of species that do, right? There's actually 3 species that you would find on Antarctica proper. But a lot of penguins don't live on this continent, as we saw in that map earlier. Okay, so we see a lot of blue. Now, this blue is important for them. Number one, it's what they're adapted to. Their feathers are really great for staying warm. And so if the water got too warm, maybe they could overheat. But what's more important is that penguins find their food in that water. And their food tends to be little fish that do really, really well in cool water. Okay, so we know that around here is a lot of cool water. So this is a great place for a penguin to be able to find food. Well, we saw that there were some penguins that lived a little further north, right? Let's take a look at South America. Actually, why don't we go back to that map? So we know we're going to be looking at South America. Let's go back to that penguin map. Let's take a look at South America here. Where do you find penguins? Okay, we find them down here at the very bottom tip. That's great. And then they are actually up the western coast here. Interesting. And then that little bloop right there. All right, let's take a look now at our SOS Explorer. And we're going to see what the water is like where those penguins live. So at the very southern tip of South America, that's right here, that water's still cool, right? It's nice and blue. There must be a lot of great food there. And I did see that there are some penguins that live on the eastern coast of South America, probably around right here. Now, these are the Falkland Islands. Actually, that's another thing I can do. I can put up an overlay, as you can see here, and then put up the country labels so we can actually see what the countries are. So this is really helpful, especially if you are geographically challenged like I sometimes am. So now down here, if I zoom in, this is a place called the Falkland Islands. And so, yes, we do find penguins here. In fact, the penguins that we have here at the Aquarium of the Pacific, the Magellanic Penguins, are the ones that are really found in this area, in the Falkland Islands and up into Chile. Would you like to see what they look like? They're pretty amazing. So here are some of these penguins. And as you can see, no ice or snow anywhere to be found. These are beach penguins. As you can see here, they do hang out on the beach. But all of that water that you see here, all of this water is nice and cool, just like we noticed on our map on the SOS Explorer. It is nice and cool, so there's really, really great fish. Great stuff to eat all around here and all around here. Okay, so we also noticed that there were penguins that even lived up the coast here. Well, it's still pretty cool, right? This is green colored water, not actually green, but when you look at temperature, and so that's still on the fairly cool side. And then there was that one little bloop of penguins right off the coast of Ecuador in the Galapagos. And that's probably about right here. Now look at that. It's still green. And it's because of the way that the ocean moves. Remember how we were talking about the ocean current and how it kind of makes a big swoop around the planet, or sorry, around the ocean in the northern hemisphere like this? Well, in the southern hemisphere, it kind of moves the opposite way. You may have heard of that kind of theory before. So that's one of the reasons why the cool water from down here is actually, from Antarctica, is actually coming up here and coming across here. So there's still cool enough water in the Galapagos to have enough food for our Galapagos penguins. Cool. Okay. Ah, there they are. Again, no ice and snow. Doesn't it look kind of like a warm place? To me, it looks like a warm place. The volcanic rock, the nice crystal blue water. I mean, it's what we're used to seeing when you think about a tropical place, like maybe even Hawaii, right? But even though the air temperature might be quite warm here, the water is still cool, as we see right here. That's why the penguins can live there. Now, we have been asked, so why don't penguins move north? There's plenty of fish up near Alaska, maybe even in Canada. There's plenty of fish up there. Why don't they live up there? Well, if you were to think about it, penguins do migrate. They actually do go out in the ocean and swim around, and then they'll come back to land a little bit later. But if this penguin, even the ones that are furthest north here, wanted to maybe hang out here in Southern California, they would have to cross this giant band of warm tropical water. Okay? Now, this band here doesn't have the kinds of fish that they are used to eating. And they might even get too warm being in water this warm. So this band, right where the equator is located, this band of warm water is actually in some ways preventing penguins from moving north. Also, they've figured out their life where they're from. It's what they're accustomed to, and so that's probably where they're going to stay anyways. But information, data, like the one that we're looking at right here is going to help us kind of understand even animals much easier, right? So I think it's a pretty cool thing to look at. Now, again, if this is something that you want to explore on your own, it's not just these two things that we looked at. In fact, when I opened up the site here, look at how much there is to see. So this is something kind of fun. I encourage you to check it out if you're kind of curious about Earth and want to see some of these beautiful images here. I am going to leave us with, if I can find it here. Oh, by the way, it's not just Earth on here. There's also some space things as well. Let's see, it is alphabetical, and that's incredibly helpful. You can also open up the tab here, and it sorts by kind of like general theme. So if you wanted to look at water things, ocean things, it's right there. Land things are up there. But let me show you very briefly another really interesting way to look at our planet. So again, it takes a little while to load, and once it loads, it does need a moment to render. So let's give it just a moment here. So we're not really going to dive into this because we don't have the time, but if you are curious and you want to look a little bit deeper, again, you can totally do this yourself if you have a computer, if you have a device like this tablet here, NOAA's SOS Explorer, but this is earthquake data. Earthquake information. And if you look up here, these earthquakes are from 2002, 2003, and it will continue to keep going. So we actually have earthquakes from 2001 to 2015. The key here, the magnitude, the size of the dot that you see will tell you the size of the earthquake, how hard the earth shook. And then down here, the colors that you're seeing, it almost looks like a party, all the flashes and colors. But the colors that you're seeing actually have meaning. It tells you how deep the earthquake originated from. So 0 is red. So the dots that are red, it's closer to the surface of the earth, the surface of the crust. Okay, and then the purple ones, it's much deeper into the crust of our earth. And so it originates from much further down, and they feel very different. So that's kind of really interesting information. But like I said, party on the planet, but wow, it's active. Yes, our planet is very active. Another thing I like kind of looking at with these earthquakes, even though I don't love maybe experiencing them so much, I love the data. I love the information. And it's so interesting to see the patterns where they'll pop up. If you watch it long enough, you can almost predict where it's going to pop up. And that's just because earthquakes are often going to occur where the Earth's crust where the plates of the Earth's crust come together. Now, if you're not really sure what that means, I encourage you to look that up because it's fascinating. Anyways, so that actually does it for us here at the Aquarium of the Pacific today in the Aquarium Online Academy. Thank you so much for joining me and taking a look at Earth in such a different way. If you have any other questions, please feel free to email us. Our email address is live, L-I-V-E, at lbaop.org, like Long Beach Aquarium of Pacific. So live at lbaop.org. I hope you have a nice rest of your day and join us a little later this week because we'll have programs for the next couple of days. Thank you. Bye.